All right, class. Right now we are going to talk about bonding. Now, before we talk about bonding, there are two things that I need to talk about. And one of the two things that you need to know before we can talk about bonding, one of them is we need to talk about electronegativity. Electronegativity, also abbreviated as EN. What is electronegativity? So we're going to have to talk about electronegativity. Here's what it is. Electronegativity, I want to write it down, is the power of an atom in a molecule to attract electron. Basically, what electronegativity is how strong is an atom. You know how some people are stronger than others? That's exactly the same thing on a periodic table. Some atoms are stronger than others on a periodic table. And we call that electronegativity, the stronger atoms. Now, what they've done, they've assigned a number, an EN number, to all the atoms on a periodic table. And the EN number goes from 0.7 to 4.0. So that is the EN value assigned to each atom. Assigned to each atom. So the strongest guy on a periodic table is going to have an EN value of 4. And that guy is fluorine. And the weakest one would have an EN value of 0.7. For example, cesium. Let me undo that. Okay. Now, what is the trend on this? So you don't actually. I'm not gonna give you the EN value on the exam. You're not always going to have access to the EN values, but what you could know, what you could figure out is when you have the trend. If you have a trend, then if the values are not given to you, you can easily figure out. So here is the trend for electronegativity. Okay, as you can see over here, as we go up, the EN increases. As we go to the right, the EN increases. So we said fluorine is right here. It has a high EN value. Cesium is down here. It has a low EN value. Okay, so now let's do a quick practice problem. Ready? Let's do a quick practice problem. Here's what I want you to do. Look at your periodic table and tell me carbon versus nitrogen. Which one is going to have a higher EN value? Okay. Now, every time you have a question like this, write down the trend. I go, okay, so the trend is I go here, I go here. Carbon and nitrogen. Nitrogen is after carbon. So if you look at these two, this way it increases. So which one is going to have a higher EN value? Nitrogen would have a higher EN value. Okay. So again, I didn't give you any values, but you can figure out without knowing the values based on the trend. So far, so good. Okay. Now, that's one thing you need to know, electronegativity. And the next thing that you need to know in order to do bonding is valence electron. Valence electron. Now, here's what valence electrons are. Valence electrons are involved in bonding. So not all the electrons are involved in bonding. Only valence electrons are involved in bonding. Now, why are they involved in bonding? The reason that they're involved in bonding because valence electrons are the outermost electron. They're the outermost electron. That means they're far away from the nucleus. If you're far away from the nucleus, you can't feel the plus charge anymore. So it's going to be easy to play around. We talked about that before. We said nucleus is the mom, electrons are the kid. You're near your mom, you can't do anything bad. You're far away from your mom, you can play around. So the outermost electrons are far away from the nucleus. They're more accessible. They are more accessible. They are more accessible. And those are valence electrons, and they're involved in bonding. Okay, now here's what I want you to do. What I want you to do, write the full electron configuration for me for sulfur. Okay, now if you do that, it's probably 1s2, 2s2, 2p6, 3s2, and 3p4. Okay? Now, which ones are the outermost electron? You have to look at the last shell. What's the last shell? This is the last shell, right? The last shells are on the third energy level. This is the last shell. On the last shell, how many valence electrons do you have? You have a 2 and you have a 4. So 2 plus 4 is 6. So what sulfur has 6 valence electrons. That means it has 6 electrons that are involved in bonding. Okay, let's do another one. Sodium. Quickly do the electron configuration, the full one on sodium for me. So is 1s2, 2s2, 2p6, 3s1. Which one is the last shell? The last shell is on the third level, right? That's the last shell. So look at the last shell. How many electrons on the last shell? 1. So sodium has 1 valence electron. So sodium has 1 valence electron. Oh, sorry about that. Let me undo that. So sodium has 1 valence electron. So valence electrons are far away from the nucleus. They're involved in bonding because they're far away. They can't feel the plus. They are accessible. They can do stuff. Now, you can do this. You can write down the electron configuration and figure out the valence electron every time. Or the shortcut is you can actually figure it out based on the periodic table. So here's our periodic table. Let's do it based on the periodic table. So you see group 1A. Group 1A have 1 valence electron. Group 2A have 2 valence electron. Group 3A have 3 valence electron. Group 4A have 4 valence electron. Group 5A, yeah, good guess, 5. And then 6 and then 7 valence electrons. So you can also figure out the number of valence electron. And the last one, noble gases, would be the 8 valence electron. So you can figure out the number of valence electron. I don't know why I circled them. Based on the group number. Okay? So let's do a practice problem right now. And answer me fast. Br, how many valence electron does Br have? Hopefully you're saying that Br has 7 valence electron. Good job. Ready for next one? Do this fast for me. Nitrogen. How many valence electron does nitrogen have? Yes, it has 5 valence electron. Okay, so you gotta remember valence electron, and you're gonna remember electronegativity for me in order to do bonding, which we will continue bonding next time. Nice job.